All right, so now that we've graphed sine and cosine, in the next section we're going to go ahead and graph the rest of the trig functions. So to begin with, let's go ahead and talk about cosecant of x and also secant of x. Now just as kind of a quick reminder, cosecant is 1 over sine of x and secant is 1 over cosine of x. All right. So what we usually do when we're graphing these functions is we first graph their reciprocal. So to begin with, I'm just going to go ahead and graph sine again. So I have 2 pi, and then we'll go over here to negative 2 pi, negative pi, and then I think I'll go up to 3 pi. And then we'll just mark down the half points in between them. Won't worry about those too much. And then we'll have negative 1. So just as a quick reminder, the graph of sine of x is going to look something like this as we go around here. So it's going to look like that. And then it's going to continue that pattern. So this graph in blue here is y equals sine of x. Now for the reciprocal, so cosecant, we're really just taking 1 over sine. So for example, notice that sine of pi over 2 equals 1. That's this point right here. If I did 1 over sine of pi over 2, that would also give me just 1 over 1, so that'd just be 1. And this is actually cosecant of pi over 2. So cosecant of pi over 2 is right there at 1. Similarly, we'll have points here at the negative 1s. So first of all, I want to point out that cosecant actually shares all of those values, 1 and negative 1 at each of those points. But now in between, some weird stuff kind of happens. So the next thing I want to mention is, let's say sine was 1/2. So at pi over 6, this is 30 degrees, sine is 1/2. Well, cosecant is the reciprocal, so cosecant is actually going to be 2. So what's going to end up happening is the graph is going to increase from the point that we see on sine. Additionally, let's say I have sine of, let's just go with 0. This is 0. Well, cosecant is going to be 1 over 0, which we saw before is undefined. And so this is actually going to create asymptotes whenever sine is 0. So before I actually complete this graph, I just want to mention y equals cosecant of x will have asymptotes whenever sine of x equals 0. So looking at the graph of sine, it looks like, in other words, this is whenever we have any multiple of pi. And so let's go ahead now and sketch a complete graph. So basically, here's what I'm going to expect to see when you draw a cosecant graph. So I'm going to create a new set of axes just because the ones up there are getting a little too busy. We'll put the kind of halfway points in between them. And what I'm going to do now is just put vertical asymptotes in there to kind of give myself some guidelines when I graph cosecant. The next thing I have to do is put a 1 and a negative 1 here. And now we are ready to graph. So these points are all shared. So usually when I'm graphing cosecant, I first think about what the graph of sine would look like. And then it sort of turns into a bunch of little parabolas going up and down. These technically are not parabolas, but they have a very similar shape. They kind of look like U's. And so this is the graph in blue here of cosecant of x. the parent function for cosecant of x. Keep in mind the vertical lines, those asymptotes are not actually part of the graph. They're more just like guidelines for the graph. Okay, let's go ahead and do secant now. And I'm going to do the same thing. First I'm going to graph cosine, so we'll go with pi, 2 pi, and we'll do negative pi, negative 2 pi. I think I have room for 3 pi, and then I'll just kind of do their halfway marks like that. We'll do 1 and negative 1. Now cosine, remember, starts with its maximum on the y-axis. It goes down and then comes back around at pi. And so it's going to look something like this. And I'm getting a little bit sloppy over here. Okay. Now for this graph, notice that the vertical asymptotes are actually going to be at the pi over 2 values, right? So whenever cosine of 0, or cosine of x equals 0, that will give us a vertical asymptote for secant of x. And this happens at all the pi over 2. So it looks like it's at negative 3 pi over 2, negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, etc. So all these pi over 2s. And then the actual graph for secant is in blue here. Ignore the graph of cosine in black and then the vertical asymptotes in red. What I have here in blue is the graph for secant. So again, these little parabolas kind of going up and down will give me the graph of secant of x. So it looks a lot like cosecant, except it's just been shifted to the left by pi over 2. Or you can think of shifting secant to the right, pi over 2 will give you cosecant. And these are the parent functions for each of those graphs. Now with both of these, I started off by graphing their reciprocals. So in the case of cosecant up here, I first graphed sine, and then I graphed cosecant. For secant, I first graphed cosine, and then I graphed the secant graph. That's how we're always going to do these. So whenever you graph a secant and a cosecant, I usually will, well, I will say always, I always first graph the sine or the cosine. But if you're able to do it without graphing those first, then you could probably do it that way. Okay, a couple more things to note here before we actually get into some problems. The domain of each of these is similar. So for cosecant, it's all real numbers except multiples of pi. For secant, it's all real numbers except odd multiples of pi over 2. Notice I have to say odd multiples, 1, 3, 5, because if you do even ones, you would get something like 2 pi over 2, which would just be pi. And then the range for each of these is also kind of weird, because now it's all real numbers except, open bracket, negative 1 to 1. So notice I've taken out sort of that middle chunk where sine and cosine would exist. So instead of writing it like this, I'm actually going to rewrite it to be negative infinity to negative 1, and then also 1 to infinity. And this is true for both cosecant and secant. We're sort of taking out that middle chunk there. Okay, finally, I want to talk about the behavior of the graph near an asymptote. And this is just kind of to remind you of something. And it will come up in the closure today. So the behavior near an asymptote. If I'm looking at cosecant, let's say I was taking as, let's go, x goes to pi. And let's say we're coming in from the right, or no, let's go left first. So if I say negative, remember this is pi from the left, and this is for cosecant. then we would say, well, y is going to go to plus or minus infinity. Let's take a look up here at our graph. So as I'm approaching from the left, notice that my graph, so as x goes this way, y is increasing forever. So that means I would say y goes to positive infinity. Oops, that does not look like a very nice infinity. And this just does not look good. Give me one moment. I was kind of looking back at my notes here. I don't like how this looks. Okay, so once again, this is for cosecant. So y is going to positive infinity. This is x to pi from the left. And then from the right, as x goes to pi from the right, y is actually going to go down to negative infinity. And all of this is for cosecant. This would be true for any multiple of pi, except the y might change from positive to negative. And you could also do a similar thing for cosine, so I'll let you think about that for cosine. You would just change the pi to pi over 2.